how do unmanned aircraft systems work? Okay, so the UAS as a whole. At the core of the UAS are simply tools. They are an extension of how we gather information and perform tasks as humans. And that's something for you developing your own knowledge of UAS. It's important to remember that UAS really are just tools. UAS continue to be used to perform more tasks and become deeply integrated as vital elements of how the industry is conducting business. All right, so we're not only doing more things with UAS, but the questions that we're answering within industries that use UAS are relying more heavily on the UAS to answer those questions. So all the way to the point where I give this last sentence here, and that, you know, UAS has evolved to be so important that there are some things we just simply can't do as an industry without UAS. And that's going to happen more and more as time goes on. All right, so what are the primary components of UAS? We sort of introduced them already. And here I'm just talking about the primary components. There's lots of different things that go into making UAS work. You know, I could argue coffee is a major component to my unmanned aircraft system, especially when you're getting going in the morning. Very important element to making sure that fourth UAS component works properly, the human component. But here I'm just talking about the four major components. The vehicle itself, then the sort of the distribution center of the UAS, the ground control system. The ground control system is going to manage how all the parts talk to each other. The payload and accessories. So the payload is the main reason we are even flying the UAS itself. The payload's going to help us answer the research question, the reason we have a UAS at the site, at the location we're flying. And then the most important, most dynamic element or component of the UAS is the remote pilot crew, the people, the human, that's integral to making all these systems work together to make the tool work to accomplish the mission. What I like about the pyramid here is one thing to keep in mind, that I'm not introducing these components in any way other than the way that I'm going to talk about them this semester. I started with the aircraft vehicle because I think that's probably the most interesting to you guys, to sort of get your attention, to get you on board with the UAS, the way we're going to talk about UAS. But it doesn't mean it's necessarily the most important component of the UAS. And in fact, I actually think that the operator is probably the most important component of the UAS in respect to replacement value. Okay, and so what I mean is we'll talk about this term 2 is 1 and 1 is none over the course of the semester. And really that's from an operations standpoint. So UAS is a technology. What do we know about technology? Technology is fragile, right? It tends to not work 100% of the time. Right? How many times have you gotten on the phone with IT and they told you restart your computer, right? It's because stuff as amazing as technology is, stuff doesn't always work when there's literally a million different decisions being made every second. What we can do is, if we have a process that's highly relied on a computer, we can buy 2 computers, right? So 2 is 1, 1 is none means that when we go out to fly a mission with a UAS and we know that we're going to need that aircraft to complete the mission, well, I would never be more than a few hours drive on a UAS mission without having 2 aircraft, all right? So I'm just going to count on that first one not working, and I'm going to have 2 of them. So we can do the same thing with the GCS, with our ground control station. We can do the same thing with our payload. So we can have 2 of each. So we have the amount of resources to sort of overcome a loss of these other components, the aircraft, the GCS, the payload. But when it comes to the operator, often as human beings, we possess intimate knowledge or specialty knowledge that is really hard to replace, right? So we have either the skills or knowledge that's going to make the operator the hardest component of the UAS to actually replace and still complete the mission. So the sort of pyramid of mission importance here, I like it because the operator, number one, is at the foundation. So if the operator is gone, the entire pyramid sort of falls apart. The operator in this situation also represents the greatest area, or if you want to put in three-dimensional terms, the greatest volume in holding the pyramid up. And so I really like the way that the pyramid looks. If you want to think about, where are the four components fit within the entire UAS, I think the pyramid's a good way to consider it. So how do all the UAS components work together? All right, and let me just say we'll spend a little bit of time talking about how each component works with the whole system as we get into details about each component. But here I just want to give you a little bit of an overview. So the extreme utility, I like that, extreme utility of UAS is based on the use of modern technology to deliver the most basic information humans use to survive. All right, so again, when you look at some of the most advanced tools that humans use, whether it's UAS or some other tools, oftentimes very complex things that we derive as humans are based on very simple things. All right, so humans can only sense we have basically five senses that we use to make a lot of decisions. While UAS are capable of doing a lot of different things, primarily what UAS do is provide visual information, right? And that's 9 out of 10 times when you're getting some awesome information from a UAS, it's just based on, things we use every day. We rely on our vision to make decisions every day. All right, so basic information, the types, that's exactly what I just said. And so what is the technology I'm talking about? So technology of the past decade really has provided UAS with three capabilities that have contributed to its utility. So digital navigation, so lightweight, unmanned aircraft vehicle, subsystem elements, monitoring and regulating thousands of electronic signals every second. So a lot of this digital technology, which has been made smaller, which is allowing millions of micro decisions to being made at a time scale that's been unprecedented as well. So remote sensing, advanced systems for information detection and storage. Here again, the shrinking of the technology of remote sensing has really allowed UAS to be constructed at a scale that's accessible to you and I. So now we have a small camera that we can slap onto a very small vehicle that's number one, easier for us to maneuver, and number two, way more affordable for us. So the access of the remote sensing technology shrinking over time has really made it possible. And then finally, communications. So communications also shrinking, allowing each component of the UAS to communicate with each other, to work together as a system. And I really like some of the images here. This is from the 3D robotics website. Most of the images here, some of them are, one of them I took myself. But here is just an image of the four components of the UAS, where we have the UAV itself, what we're talking about here at the top. To the left is the ground control station. To the right, the payload. And at the bottom, the primate at the making it all happen. I don't want to say at the center, because in my mind, and I'll introduce another graphic when we talk about the ground control station, but the ground control station really is at the center of the UAS where the operator is just sort of in charge of everything. We have to be involved with every single component and every single process that happens with the UAS. All right, so what is the main purpose of each UAS component? Here's just, again, a little bit of an overview. The aircraft, the main purpose of the aircraft is to deliver the payload to the desired location, all right? So keep that in mind. The entire purpose of the aircraft is just to take advantage of the locational advantage of where we can stick that payload, all right? What's the main purpose of the ground control system? The GCS is the communication center for all the other UAS components. It's going to allow us to talk to the vehicle. It's going to allow us to interface with the vehicle, and it's going to both receive information from the vehicle, relay it to us, and it's going to take information from us and relay it to the vehicle. All right, the payload is the main reason we are using the UAS to begin with, and defines the utility of the system. All right, so unless you're using, all right, and I just thought of an application where the aircraft itself is the main reason we're flying, right? So you start a campfire, it's about to go out, there's a little bit of coals in the bottom of the fire, and because of your emphysema, you can't blow on the fire. So I'm going to fly my UAV over the fire, and the prop wash I'm going to use to fan the flames. Okay, there is a reason to fly the UAV itself. Other than using prop wash to do something with the wind it produces, the main purpose of flying every other UAV mission, every other UAS mission, is based on the payload. Payload is the main reason we are using a UAS to begin with. And then finally, the operator. What is the role of the operator in the UAS? The overseer, the planner, the fixer, the pilot. The operator must monitor and maintain the function of all system components, including component number 4. All right, and we will spend a lot of time talking about crew resource management and human factors when we get into component number 4, because it's important that we understand ourselves, understand our fellow crew members.